Hello, everyone. I'm Anshul Malhotra, and I'm the head of research here at XRPL. Recently, I had the opportunity to co-author the technical specification to add native support for an automated market maker on XRP Ledger with David Schwartz. And I would say that I'm lucky enough to get a full 30-minute slot to talk about decentralized exchange and automated market maker today. So without further ado, let's start. Before diving into the details of automated market maker, let me give you some background. So liquidity, how do we define liquidity? Well, liquidity is defined as the availability of liquid assets to a market, and the liquidity status of a market defines the ease and efficiency with which a token can be bought or sold on the market without significantly impacting the price of the token. Now, in order to enable decentralized liquidity and to enable efficient transactions on the ledger, we need that technical capability that is a market on the ledger. Decentralized exchange, these are those markets that are a crucial source of liquidity and that provide a peer-to-peer market for the traders to directly trade in a non-custodial manner without the need of an intermediary. Now, in terms of trade execution models, decentralized exchanges provide a unique opportunity with two different flavors or implementations of trade execution. The one is centered around the limit order book based DEXs, and the other one is the automated market maker. So what's a central limit order book based DEX? It's like traditional exchanges, which maintains an aggregated ordered list of bid and ask offers in the order book that are submitted by the traders. And a claw-based DEX facilitate trade execution by matching the incoming offers to that in the order book and fulfilling them. And claw-based market makers, that is, those who provide liquidity to these markets, make profit from the bid-ask spreads. Now, in terms of pros, the claws are ideal for highly liquid markets. That is, the markets where the liquidity is high, meaning the spreads are smaller because the depth of demand and supply at each price level is high. Also, they give greater flexibility to the traders by allowing them to execute limit orders. However, the downside is that the claws are not as optimal for the illiquid markets, because if there are no matching offers for the incoming offers, the traders might have to wait for long periods of time in order for their trades to be executed. And second, I think most importantly, it's really hard to scale order book-based DEX on public blockchains because of their expensive and limited storage capacity. Well, decentralized exchange on XRP Ledger, currently we know that XRP Ledger has a decentralized exchange, which is a limit order book-based exchange, and it has been running continuously since 2012. In fact, we were the pioneers in that. And I would be remiss if I didn't mention the great features of this ledger on XRPL. XRP Ledger, the order book on XRP Ledger consists of XRP token as well as token-to-token currency pairs in its order book. For trade execution, users trade via offer transaction, which is basically a limit order that is used to exchange certain value of a currency for certain value of another currency. These offers may be fully or partially consumed, and if an order is not fully consumed, it becomes an object in the order book and can be later consumed by other offers or cross-currency payments. Now, this allows for these offers to be executed generally at a better than requested initial exchange or at the requested exchange price later on. Additionally, these offers can be deleted manually or automatically after being placed, and for more details, you can look online. One of the main features of this DEX on XRP Ledger is its auto-bridging feature. It provides better exchange rates and more liquidity by automatically making XRP to token and token token to XRP and XRP to token exchange if direct token to token currency exchange is not as suitable. So it provides a better exchange rate by auto bridging. All right. So we do have an order book-based exchange. So why do we need an automated market maker on XRP Ledger? Well, for the rest of the talk, I'll try to explain why do we need an automated market maker on XRP Ledger. But let's first understand what an AMM ecosystem is and what an AMM is. So these are the main participants in an AMM ecosystem. The first is the liquidity providers. These are the agents that add liquidity to AMM instances pools. Then we have traders who can actually swap one asset for another for a fixed fee. And these could be speculators, arbitrageurs, or app users. And third is the developers who can integrate directly with the AMM DEX pools to build killer applications by interacting with tokens, trading interfaces. You can think of applications such as wallets and DEX aggregators. So what's an automated market maker? An automated market maker is also a type of decentralized exchange protocol that pool liquidity from the users. And for trade execution, it uses a mathematical formula that takes into account the current liquidity of the assets in the pool and provide an instant quote for the trade. So instead of referring back to the order book to get a price quote, you'll get it as a result of a mathematical formula, of a predefined algorithm. Now, liquidity providers on AMM usually make profit from trading fee as well as liquidity rewards. Compared to a club, AMM always provides a price quote for traders. Even if the markets are illiquid, the pricing could be bad, but it will always provide a price quote. It also provides better incentives for the liquidity providers to earn passive revenue. And in general, AMMs are more intuitive to use and hence provide a better user experience. So when we say that why do we need an AMM? Well, an AMM, as you can see, provides a different model for liquidity provision. It provides a different model for trade execution and a different incentive mechanism. So it targets a different and unique segment of traders, of LPs, and use cases. And on XRP Ledger, in combination with the cloud-based DEX, it provides the best of both worlds. Now that we are a little bit convinced that it's a good idea to have AMM on XRP Ledger, the next thing is to think about how do we design AMM on XRP Ledger. And one of the things to think about is the interest of the participants in the ecosystem, because each play a significant role in the AMM ecosystem. So to design a thriving AMM ecosystem, we'll look into the motivation for participation for these participants in the AMM ecosystem. So for instance, what do LPs want? They want to maximize returns, that is their passive income from their token holdings. Traders, they want to get best pricing on trades with low slippage. Arbitrageurs, they want to make profits off of asymmetric information. And developers want more liquidity to efficiently implement their applications. The second thing to think about while designing an efficient AMM ecosystem is to look at the points of friction in the current designs of AMMs on other blockchains. So there is no free lunch. There are some of very well-known inherent problems in AMM, some of them being impermanent loss. I'm sure all of you have heard about this term. It's the opportunity cost of providing liquidity with your tokens versus holding them. Because as the difference between the prices in the assets in the pool increases, the LPs experience more and more impermanent loss. Second is the slippage, which is the price difference that occurs between submitting and confirming a transaction, which essentially means that a trader might receive fewer tokens than they expected, especially during the periods of high volatility, or the pools with low liquidity can result in high slippage. Third is the MEV, that is the miner extractable value. For AMMs that exist on proof of work chains, we know that miners can prioritize the transactions that they process based on the gas fee, which delays transactions for the users. and can be profitable for the miners. Another problem is price arbitrage. While arbitrage is necessary for a functioning marketplace to maintain the accurate pricing, an arbitrager's profit usually result in diminishing profits for the liquidity pool. And last but not the least, we all are well aware that smart contract-based apps, AMMs being one of them, are notorious for programming bugs. So now in the last two slides, we have established what we are solving for, who we are solving for. Let's look at some of the XRP ledgers, and I'll not spend too much time on it. We all know that the XRP ledger has quicker, cheaper, and fairer transactions, which already make it more suitable, more effective, and more lucrative to build an AMM on top of it, because it would return more liquidity. It can accommodate more liquidity at lower prices, and also provides better returns for the liquidity providers. This gives us a segue to, I'd like to talk about the key differentiating features of our AMM proposal on XRP Ledger, which leverages both the inherent advantages of the XRP Ledger as well as some of the novel design features that we have added to AMM to solve for the problems that I talked about on the previous slides. So first is the protocol native. This is an AMM which is protocol native, meaning AMM's native fixed function code allows it to inherit the natural advantages of the XRP Ledger, thus making it more efficient, cheaper, and secure compared to AMMs on other blockchains. No front running or MEV. It's another benefit that is inherited from the XRP Ledger's federated consensus mechanism, because there are no miners or block producers that can prioritize transactions based on fee, and thus this problem does not exist on XRP Ledger. Now, other than leveraging the cool design features of XRP Ledger, we have added some novel, innovative features that further differentiates it from the AMMs on other blockchains. The first one being the continuous auction mechanism. And I'll talk about it in details later in the talk. But this feature allows a lot of profit that would otherwise just go to the arbitrageurs to be split between the arbitrageurs and the liquidity providers. And this enhancement basically provides benefits for all the participants in the ecosystem, meaning the LP providers get better returns, arbitrageurs get efficient and fair chance to capture volatility profits, and the traders always get liquidity because there is lower downtime. Another feature is the DEX integration. So on XRP Ledger, the CLOB, that is the central limit order book based DEX, and the AMM have excellent synergies. We combine both, aggregate liquidity from both, meaning it provides better liquidity and hence better pricing, providing the best of both worlds. Another feature is the single-sided liquidity provision. So this means usually on most of the AMMs on other blockchains, one has to deposit, they only allow for equal asset deposits and withdrawals, but we allow for single-sided LP withdrawal, meaning any deposit and withdrawal, meaning anyone can easily participate as an LP. Only a single asset is required to contribute to a pool. The protocol behind the scenes swaps on an LP's behalf to maintain the ratio of the assets in the pool, thus decreasing the number of steps for the users and improving the user experience. All right, so now let's get into the technical details of the automated market maker on XRP Ledger. Well, because of the newness of AMMs, a lot of AMMs have tried different mathematical models, different economic models, different security models to design AMMs. Some are very specific, some are more general. We choose a weighted geometric mean market maker for price discovery, It allows for creation of pools consisting of two tokens, which can be weighted outside of the standard 50-50 distribution. What this means is that now we can have different exposures to tokens within a pool by adjusting their respective weights. And this allows to accommodate for a to create efficient markets for a wide range of token pairs, which could be highly correlated or uncorrelated. Second is the spot price. This is just the glossary. So the spot price is the price for an infinitely small trade, and it's defined as the ratio of the tokens in the pool. Liquidity provider tokens represent the liquidity provider's shares of the AMM pool. So whenever you deposit liquidity, you provide liquidity to the pool, what you get back is the LP tokens that represent your share of the pool your share of the pool. And flexible swap fee, that is the fee paid by the trader for trading against the AMM instance. And it's a votable parameter. Those who own the LP tokens for the respective AMM instance can vote for the trading fee for that AMM instance. So how do we represent an AMM instance on the XRP ledger? We propose to use the existing account root ledger entry. Plus, we introduce a new ledger entry that is called AMM. And together, these two together represent an AMM instance on the XRP ledger. So for the account root ledger entry, we introduce one new flag, LSF AMM, and if set, it represents an AMM instance. And the account root ID is derived as a function of the issued assets to make it unique per asset pair. We do not allow for multiple pools per asset pair. And the new AMM ledger entry has the following fields. The first is account root ID, which is the account root ID of the corresponding account root object. The trading fee, which specifies the trading fee in basis points that is to be charged for trading against that specific AMM instance. Vote slots keeps a track of the votes for the trading fee. I'll talk about it more later. Auction slot keeps a track of the auction for the AMM instance. LP token balance specifies the outstanding number of LP tokens that belong to the specific AMM instance, and AMM tokens just specifies the tokens that this pool consists of. And this is mostly for bookkeeping. We introduced a new transaction called the AMM instance create transaction. It's a special transaction that is used to create the AMM instance. And among other fields, one must specify the two reserve assets for the AMM pool, that is asset 1 and asset 2. And they must specify the trading fee for this specific AMM instance. Now, if this transaction is successful, it creates two new objects, that is the account root object and the corresponding AMM object that is associated with this AMM. And the LP tokens are issued and they're tracked via trust lines. Now, why do we call this transaction and these objects special? Because they have some special properties. So first of all, this account root object and AMM object, their regular key is set to account 0, and the master key is also disabled automatically, because in order to disable any way of signing transactions from this account, because no one owns this account, so they should not be able to sign transactions. Second, unlike other ledger objects, there is no reserve requirement for these objects. Instead, there is a higher transaction fee in XRP, which is burned as a special transaction cost. And third, unused accounts are automatically deleted. And when is an account unused? An account is unused, an account root object is unused if there are no accounts that have trust lines with the specific account. Next is, how do we trade against this AMM instance? So we introduce new transactions, that is the AMM deposit transaction and AMM withdraw transaction to respectively deposit and withdraw liquidity. And we propose to use the existing payment transaction to swap assets within the pool. So an AMM deposit transaction, as the name suggests, is used to add liquidity to the AMM pools, thus obtaining some shares of the instance's pool in the form of LP tokens. Some of the fields that one can specify for this transaction is the two assets. Since we allow for both single-sided and double-sided liquidity provision, one can either specify one asset or both assets. E-price, that's the effective price. So spot price gives you the price for infinitely small trade, but the effective price, which is the ratio of the tokens out to token in, gives you the actual price of a specific trade, right? So in an AMM deposit transaction, one can specify the threshold to the effective price of that trade. And then LP tokens, one can also specify that this is the maximum number of LP tokens that I want out of this trade, and the algorithm will work accordingly. Similarly, for AMM withdraw, which is used to remove liquidity from the AMM pools, thus redeeming some share of the pools that one owns in the form of LP tokens, and similarly, you can specify different fields based on how you want to execute the trade. Now, since we allow for both single-sided and equal asset deposits and withdraw, we know that the trading fee is charged only on the amount of currency that actually changes the ratio of tokens in the pool. And a single-sided deposit basically is a combination of equal asset deposit and a swap. So we take care that the fee is only charged on the amount that changes the ratio of assets in the pool. This is interesting, payment transaction. So how do we use payment transaction to exchange one asset of the AMM instance for the other? So these are some of the fields. If you think innovatively, we can use it to actually swap the assets. So these are the fields of the payment transaction. So generally, an amount field would mean the amount of currency that the trader wants to deliver to a destination account. In the context of a swap transaction, we can think about it as the amount of currency that the trader wants to swap out of the pool. Similarly, for destination, it's the account that the trader wants to deliver the currency to. For swap, it is the account that the trader wants to deliver the swapped out currency to. And this could be the account that the trader owns or wants this amount to go to. Then there is this field called send max, which basically specifies the maximum amount of currency that the trader is willing to send from the account issuing the transaction. In the context of swap, this is the maximum amount of currency that the trader is willing to swap into the pool. And last, there is this TF limit quality flag, which is used to specify the quality of a trade, which is essentially the ratio between the amount and the send max. Now, we can use it in the context of swap to specify a threshold on the spot price of the currency, which is swapped out of the pool after a trade. Now, an arbitrager, you can think about it like an arbitrager might want to do a trade where they want to move the price of a certain currency from point A to B. And this is that threshold. This point B is X. This is that threshold that they want on the spot price of the currency out from that trade. And we can specify that using this TF limit quality flag. I know it's a little confusing to wrap your head around. You don't have to memorize everything. Everything is specified in the specification, so I'll highly recommend go check it out. All right, so the next feature, AMM instance votable trading fee. As I mentioned that we allow for the trading fee to be votable by the LP token holders. To this end, we introduce a new transaction, that is the AMM vote transaction. So any account that holds the corresponding LP tokens can vote for the trading fee. They have to specify the AMM ID that specifies the account ID of the AMM instance that they want to cast the vote for. And the fee value specifies the trading fee value that they want to cast the vote for. And we introduced this new object field, vote slots, that keeps that keeps the track of up to 8 active votes in the AMM object. And it's for bookkeeping again. It contains the account field, which specifies the account ID of the LP who cast the vote, then fee value, the value of the trading fee, and the vote weight, which specifies the number of LP tokens that are owned by the account that cast the vote. And this is important because the trading fee is computed as a weighted mean of all the current votes in the vote slots field. We chose to make it a votable parameter versus hard coding it in the protocol, as is the case with most of the AMMs, because we think that LP token holders, they are the biggest stakeholders. They are in a good position to make a rational decision on what the trading fee should be for a specific AMM instance. All right, now my favorite part, the continuous auction mechanism. I'll explain it, but first let me tell you the problem that it solves. So this is a well-known problem with the AMMs, that is the volatility or asymmetric trading that causes the relative price of assets in the AMM pools go out of sync with that of the external markets. And we know that AMMs do not adjust the prices automatically due to the lack of external market information. So what happens as a result is that arbitrageurs intervene. But there's a problem. They have to wait until the profit from the transaction exceeds the trading fee. And second, they have to race or compete against other arbitrageurs, which reduces their success probability. What this implies is that during this wait window, while arbitrageurs are waiting, there is a decreased trading volume and thus decreased revenue for the pool. And second, when the arbitrageurs arbitrage, LPs lose because they make profit off of LPs' expense. I'll skip this, that what are the existing solutions. They have drawbacks. But our solution is the continuous auction mechanism. We think out of box. Instead of eliminating with other approaches, try to eliminate the problem of this volatility or asymmetric trading. Instead, we try to think that how we can optimize this problem for all participants. So we take a different approach. We create a mechanism that makes it easier for the arbitrageurs and also reduces the impact of impermanent loss for the liquidity providers. So the continuous auction mechanism, the AMM can sell off trading advantages for 24-hour periods at near zero trading fee. And the proceeds from this auction are divided between the previous slot holder and the AMM pool. So the expectation is that as the slot holder will have significant advantages for arbitrage, they will bid up the price of the auction slot to nearly the value that they expect to extract through this arbitrage. And as a result, we eliminate wait time and race condition for auction slot holder because now they do not have to wait before, now the arbitrageurs don't have to wait. Second, it reduces the impact of impermanent loss because there is this reduced window, there is no wait window. And additionally, liquidity providers reap a share of profits that would otherwise go to the arbitrageurs. Do I have 2 minutes? No? Okay. I'll skip this. Continuous auction mechanism, how we design it. There is a pricing scheduling algorithm. I'll skip to the end. The revenue is split between the current slot holder and AMM pool. Then I talked about AMM and CLOB integration. The timeline is we released the spec last quarter. At the end of this quarter, we'll have a DevNet release most likely, and then amendment and the mainnet release are unknowns. All right, thank you.